Good morning to everyone. I'm Marcello Pietri, a PhD student of the 26th cycle. My tutors are Engineer Riccardo Lancellotti and Professor Michele Colaianni. As showing in the schema proposed in the previous D-Day, my research activity has moved from the wireless and the sensor network field to the cloud scenario. In particular, to cloud architecture, cloud computing, a huge amount of data to manage, the big data scenario, and to the scalability, and in particular to monitoring. In this scenario, there are important open challenges that must be solved in order to manage this huge amount of data. This big data that will be not uncommon in a near future. For instance, Google Envision is for 10 million server or 10 million of physical nodes in the next year. And our system must be able to scale to at least 1 million of heterogeneous data streams, and it must provide the access to the single performance samples or graphs within a reasonable real-time or quasi-real-time constraints. And it also must not have any single point of failure, or it must be robust. And finally, it must reduce the expected time for the user to retrieve more sophisticated analysis. In this sense, we propose an architecture designed to dominate the complexity of the monitoring problem and to avoid the single point of failure. How? First, with the decentralization of the monitoring infrastructure. Each cluster is equipped with its own monitoring infrastructure. Second, processing the data as close as possible to the edge. The data are initially filtered at the monitoring nodes. Third, operating in batches. Little and small random requests to the databases suffers from overheads. We batch this operation in big ones, and this helps our solution. Finally, with the redundancy of every monitoring component, using software easily replicable. So we develop an architecture and a prototype that can be summarized with the following schema that was presented at the international conference called the INFQ at Lucca. We not have enough time to explain all the details of this architecture, but starting from the prototype, we obtain significant results that was presented to IEEE and CCA conference in London. Some of these results regard the scalability of the whole architecture, also the performances of MapReduce scripts able to gather and analyze the whole data, the big data. This simple schema is a good summary of the result we obtain at each steps. In particular, in a single cluster, we can collect, process, and store more than 3 million metrics per second in each cluster. And metrics that comes from about 1,000 physical nodes with a sampling interval of 1 second, 3 million metrics per second, with a resource consumption in a whole architecture that is less than 10%. Concluding, we have proposed a scalable, reliable, and open source architecture for the monitoring of a large number of resources in data centers. And the proposed architecture is able to collect data from multiple sensors and resources. And it also grants secure delivery to remote centers where advanced analysis and value-added services can be provided, and is now integrated with online analyzers working at different temporal scales. And finally, it ensures the availability and the scalability to cover the large-scale deployment scenarios. About the future work, the next PhD year, the focus is on scalable monitoring and analysis of geographically distributed system and complex system, and on novel architecture and algorithms for evaluating bottlenecks and analyzing the whole system state. And last but not least, the solution for aggregate and reduce data MapReduce to foresee the future behavior. So thank you to give me the possibility to briefly outline my research activity, and thank you for the attention.
Thanks for your talk. Any question? Which are the applications specific applications? I'm thinking about the practical side of this story. You are thinking about, for instance, the smart grid or something like that?
No, we apply in a cloud scenario,
okay.
typical to Amazon EC2.
Okay. I was thinking about collecting a large amount of data, for instance, acquiring different houses, smart houses or something like that.
No, now to cloud scenario.
Okay, thanks again. So we have the last talk given by Ms. Stefania Tosi, and after that, the first day of the day is over.
Cos'è questo coso?